All right, so here's what we're going to do on this page of the notes. We're still dealing with a quadratic that is in standard form, and you've been asked to put it in vertex form, but this one's got an extra little wrinkle to it, and it's this. My leading coefficient is not a 1, and we know that in order to complete the square, I need that leading coefficient to be a 1. So we're going to take a look at what you're going to do to deal with this particular situation. And so we start off with y equals minus 3x squared plus 6x minus 1. Well, since I still, it's a y equals, so I have to do all my work on the same side of the equation, right? I can't work on both sides. I need that to stay a y equals. So we're still going to need parentheses. And let's go and put parentheses around my quadratic and my linear term. Now, what I would be ready to do at this point was I'd be ready to go ahead and complete the square inside the parentheses. And since I'm going to add a b squared over 4 inside the parenthesis, I'd have to subtract the b squared over 4 on the outside of the parenthesis. But before I can complete the square inside the parenthesis, I need this leading coefficient to be a 1. Well, the way that we're going to do that is we're just going to go ahead and pull a negative 3 out of everybody inside the parentheses. That's going to leave me with an x squared minus 2x, and then that minus 1 is still out back. Okay, great. Well, what I've now done is I have a leading coefficient of 1. But here's what's happened. I have pulled a negative 3, right, out of both my quadratic and my linear term, right? My b originally was a positive 6. But because I've factored out a negative 3, now my b is a negative 2. That is the b that I'm going to use to complete the square. But this adds an extra little wrinkle here when I subtract my b squared over 4 on the end, and I'll show you what we're going to do when we get to it. So I have y equals minus 3 x squared minus 2x plus b squared over 4 minus 1. Now, since I added b squared over 4 inside the parentheses where my b is a negative 2, I'm going to have to subtract b squared over 4 outside the parentheses. But there's one extra little piece you've got to remember here, and it's this. Remember, I pulled a negative 3 out of my b. I pulled out a negative 3. So when I calculate b squared over 4, it's missing the negative 3 that I had pulled out in order to get a leading coefficient of 1, which I must have, right? It's got to be a leading coefficient of 1 in order to complete the square. But the issue I'm running into now is that this b squared over 4, right, that I'm subtracting out here is missing something. And what's it missing? Well, it's missing that negative 3. Now, why, right? I say missing the negative 3. Here's what if you were to multiply this guy back out, right, I would distribute the negative 3 through the parentheses, right? And this b squared over 4 would get that negative 3 back, right? I pulled out the negative 3, I complete the square, distribute the negative 3, and I would put my negative 3 back in. But when I distribute the negative 3, it doesn't make it all the way out here. It only gets distributed through the parentheses, right? So how do I account for the negative 3 that I pulled out? I've got to remember. I have to remember to put that negative 3 back. So we're going to put a negative 3, right? We're going to multiply this b squared over 4 by the negative 3 that I had pulled out in this step right here, right? Because I pulled out a negative 3, you're going to have to remember to put that negative 3 back. All right, here we go. Y equals minus 3 x squared minus 2x. My b is a negative 2. Negative 2 squared would be 4. 4 divided by 4 would be a positive 1. Negative 1. Since I added 1 inside, I'll subtract 1 on the outside, but this negative 1 is missing the minus 3 that I had pulled out in this step. So I've got to put that minus 3 back, multiplied by a negative 3. Y equals negative 3. This is now a perfect square trinomial, so go ahead and factor it. Let's see, it's going to be a negative 1 and a negative 1. And then out here I have a negative 3 times a negative 1, which would be a positive 3. Minus 1 plus 3 should be plus 2. And one last step to get it into vertex form. These binomials are the same, so write them as a quantity squared. And this is now in vertex form. You can quickly recognize your A, your H, and your K. A is equal to a minus 3, H is equal to a negative 1, K is equal to 2. So I know that what this does is when that leading coefficient for your quadratic is not a 1, it adds an extra little wrinkle in these problems. Just one more thing you got to kind of watch out for in order to get it into vertex form. But we'll practice a few of these and you'll get the hang of it after trying a couple more. So let's do that. Next page of the notes, I have another one here for you where my leading coefficient is not a 1. So we're going to need to make it a 1. But before I do that, I have to introduce the parentheses I'm going to use to help me complete the square. Now, before I complete the square inside the parentheses, I need that leading coefficient to be a 1. So I'm going to need to pull out a negative 2. That's going to leave me with an x squared and a minus 4x. Now, I am going to add b squared over 4 inside the parentheses, but that b squared over 4 is going to be missing the negative 2 that I had pulled out. So when I subtract b squared over 4 outside the parentheses, you got to remember to put that negative 2 back. The negative 2 you pulled out, you got to remember to put it back. Add b squared over 4 minus 3. I will subtract. I added b squared over 4 inside the parentheses. Subtract it outside the parentheses to maintain equality. But, right, I pulled a negative 2 out, so I've got to remember to put that negative 2 back in. All right, let's go ahead and do that. My b is a negative 4. Well, negative 4 squared would be 16, and 16 divided by 4 would be 4. This is now a perfect square trinomial, so we'll factor it into its binomials, which is easy to do. Negative 4 times a negative 2 would be a negative 8. Negative 8 and a negative 3 should be a negative 11. I'm going to need minus, so they both have to be negative. 4 is a perfect square, so they have to be the same number. In this case, it's going to be a 2 and a 2, and you are almost done. Last thing you'll need to do is write it as a quantity squared. And you can now quickly recognize your A, your H, and your K, which then will allow you to quickly make transformations to the parent function and graph this quadratic relatively easy. All right, so guys, we'll try a few more of these on the next page of the notes, so head on over there and I'll meet you guys on the next page.